everybody, or good afternoon and good evening, depending on where you are joining us from. My name is Isaac Montoya, and I am the Director of Marketing here at Upside Technologies. First and foremost, I would like to thank you all for joining us here today for week one of our 6th annual Airflow Management Awareness Month. We started this back in 2015 with the intention to really raise awareness around airflow, but also cooling optimization and data center energy efficiency in general. And we are happy that we've been able to push it this long. It's our 6th year doing it. And if you also notice at the top of the presentation, we are also celebrating our 20-year anniversary as a company here at Upside Technologies. I'll be joined here shortly by Mark Acton, Independent Consultant and Non-Executive Director at EchoSense, who will be headlining today's webinar, as well as Lars Strong, Senior Engineer and Company Science Officer here at Upside Technologies, who will be giving a brief introduction for today's presentation. Before I pass it off, I'd like to go over just a couple quick housekeeping items. Everybody will be muted throughout the duration of the webinar, just to cancel out any background noises. But we do encourage you to ask as many questions as you would like, and you could do so using the Q&A module located in your Zoom dashboard. Also, if you happen to have any audio or video technical difficulties, please feel free to shoot me a message in the chat module, and I'll try to get that resolved for you as soon as possible. So, as I mentioned, we are joined here today by Mark Acton, who is jumping us off here for our 6th annual Airflow Management Awareness Month. Mark's going to be talking about data center energy efficiency and sustainability and examining the key elements for planning for a path forward. Next week, we'll be joined by our very own Lars Strong, who will be going over different containment considerations and how to determine the right solution for your facility and how to maximize the ROI from those containment solutions. And then in week 3, we'll be joined by Bill Clayman, Executive Vice President of Digital Solutions, who will discuss the perimeter-less data center and touch on security, automation, and robotics. And then in the 4th and final week, we'll be joined by John Gross, owner and engineer at JM Gross Engineering and ASHRAE contributor, who will discuss what's new in ASHRAE's 5th edition of thermal guidelines and how it can impact your facility. So if you haven't already registered for those sessions, we'll be providing a link later in this webinar for you to do so if you would like. Now, without further ado, I'm going to pass this off to Lars for a brief introduction.
Thank you, Isaac. Well, we are really excited to have Mark joining us today to discuss this important topic. It's really a comprehensive overview of a lot of what we bring to the industry and a lot of what needs to be considered. You know, for those of you who don't know, Mark is a contributor to our Upside Technologies blog, where he has written about emerging trends, data center metrics and standards, and also on today's topic, data center energy efficiency and sustainability. Tell you a little bit more about Mark. He has over 25 years of experience in the data center industry and has been a specialist in the field of data center operations for over 20 years. Concentrating on the delivery of business critical services from highly reliable world-class data centers having 24 by 365 day a year availability expectations. You know, this has included consultancy and technical advice, as well as senior management roles responsible for service delivery. And that's both on the strategic and operational management level within the industry. Mark is a technical operations manager with extensive international experience and solid technical skills, covering data center facilities design and IT and facilities operational management. Mark is also a regular public speaker, conference host, and industry advisor on data center technical issues. He's currently acting as consultant and non-executive director for leading data center operators and solutions developers, as well as being involved in international data center standards development. Obviously, that being very important for today's topic. You know, so it goes without saying that Mark brings a wealth of knowledge to this very important topic. You know, as many of you know, standards, metrics, and certifications are a big part of our industry. They do help us move forward in terms of efficiency, reliability, capacity, and many other areas. But as well, we know that data centers consume a large amounts of energy. And as our industry continues to grow and be heavily relied upon by the global economy, the spotlight on data center efficiency is getting brighter and brighter. But regardless of the attention put on our industry, doing all we can do to be as efficient as possible is simply the right thing to do. There are a number of things that can be done already to improve efficiency. Some of the largest data center operators have already demonstrated that. But what has really been lacking in our industry are comprehensive metrics to guide us all forward so that we can all share data and all improve together. And those with less deep pockets can have some guidance for what they can do to improve. So I will now hand the presentation over to Mark to untangle some of the myths that surround efficiency and sustainability, and to provide insight into what we need to be considering to move our industry forward. So Mark, the floor is yours.
Thanks very much, Lars. And thanks, Isaac, for the intro. And thanks very much to Upsite Technologies for inviting me to speak. And finally, thank you, everybody, for joining us. And I hope you enjoyed the session. So I'm just going to make sure I can actually move on to the next slide here. Sometimes takes a little while to respond. Oh, here we go. So what I'm going to do, a very quick agenda. I'm going to run through some of the myths and some of the detail around what is carbon neutral versus net zero carbon. Two terms that we hear a lot, but are used somewhat incorrectly and interchangeably, and they're not the same thing. Then go into a little bit about data centers and sustainability generally. Then a little bit of a feature on energy efficiency, what actually is energy efficiency in the data center, and then maybe a glimpse of the future, or at least my version of the future. It may not be the future, but my crystal ball may have a slightly different path than other people's. Nonetheless, we'll have a look and see how that goes. So the first section is carbon neutral versus net zero carbon. Let's go into that in a bit more detail. What is carbon neutral? Well, carbon neutral is all about balancing the greenhouse gas emissions by offsetting or removing from the atmosphere an equivalent amount of these produced. Okay, so what does that really mean? What it really means is that we have to essentially put no more carbon into the atmosphere than we're actually offsetting, than we're actually either sequestering, which is removing, or preventing, or indeed offsetting by putting something in place which offsets the emissions that we're producing, i.e. planting trees or something of that nature. The challenge with carbon neutral, one of the issues with carbon neutral, is that we can achieve it by essentially buying credits. Again, we can offset by planting rainforest, or well, just forest generally. We can actually buy other people's permission to produce carbon. So it allows us to basically still continue to produce carbon and still emit greenhouse gases without necessarily reducing what we're doing. So that third bullet there, it's a really important element of carbon neutral, is that a carbon neutral business can actually increase the emissions it produces. It doesn't necessarily mean that a business is reducing its emissions. All it means is that it's essentially moving the problem elsewhere. It's either buying someone else's permission to produce carbon, it's offsetting by planting trees or something of that nature, which is not in itself a bad thing. It's good to improve the environment, but that is, planting trees and whatever is in itself unsustainable. We cannot plant sufficient trees to offset all the carbon. We've actually got to reduce the amount of carbon we're producing. So I think it's very important to realize that carbon neutrality does not necessarily imply or even require a commitment to reduce overall greenhouse gas emissions. And we talk about carbon a lot, but obviously we can throw into there methane, we can throw into there the fluorohydrocarbons that are used in refrigeration systems, etc. Generally when we speak about carbon neutral, we are talking about greenhouse gases in general, not just carbon, not just CO2. But nonetheless, it's important to realize that this carbon neutrality is potentially a mechanism whereby large carbon producers can merely move the problem elsewhere without necessarily reducing their overall greenhouse gas emissions. And I think it's a very, very important point to be aware of. Let's move on to the next slide. Again, I'm not sure it's working for me. Great. Net zero carbon is a different thing. Again, the two terms are used interchangeably, or can be used interchangeably. Net zero carbon does require a reduction in greenhouse gas emissions, and that is the big difference. It's not just as simple as being carbon neutral. It's not just as simple as saying we can move the problem elsewhere. Net zero carbon actually, again, requires us to reduce the overall level of emissions that we're creating or putting out there. And to make this achievable, or to make it something that can actually be measured and properly referenced, the targets are set by an institute called the Science-Based Target Initiative, SBTI, and I'm not going to go into all sorts of detail about who they are and where they are. The link to their website's there. But there's two important statements that they make, and I think these are sort of the high-level statements that people should be aware of. To reach a state of net zero emissions, companies need to basically apply two conditions. They've actually got to achieve a scale of value chain emission reductions. And this is the important point, it's reducing the overall reductions, which leads to a limit of warming to 1.5 degrees Celsius. So what we're in effect doing is we're limiting, or we're agreeing to limit the amount of greenhouse gases we're producing, which will be consistent with a limit in temperature increase of 1.5 Celsius. And also it's to neutralize the impact of any residual emissions that remain to be eliminated by permanently removing an equivalent amount of atmospheric carbon dioxide. And that does include things like embodied carbon. So we obviously over time have released a great deal of carbon by burning fossil fuels. We are continuing to do that by continuing to burn fossil fuels. We need to reduce those emissions. And it's not just what we're actually reducing into the atmosphere. We need to actually reduce what we're embodying in equipment or in the buildings that we produce. So when we pour concrete, we need to consider the amount of impact, the carbon impact of that concrete. Do we use regular concrete? How much of it do we use? How much cement do we produce or use as part of that concrete? There are low carbon cements and concretes available. So should that be an option? Should that be something we're doing? Yes, ultimately it probably should. But let's not just think about the building. Let's think about the IT equipment that we're actually, manufacturing and using, and hopefully disposing of in an appropriate manner. So we need to consider the embodied carbon in the manufacture, in that equipment, and not just the carbon. Again, we're talking about greenhouse gases here generally. As we know, to manufacture IT equipment, we're using a lot of relatively difficult to obtain minerals and elements. What is involved in those production methods, what is involved in those extraction methods, and therefore what sorts of carbon impact are we having during the manufacture, use and disposal. So the scope 3 emissions that we talk about here are those that are used during construction, during manufacture, and result in so-called embodied carbon. It's all about the extraction, it's all about the manufacture, and it's all about the disposal. At the moment, we don't have a particularly good handle on scope 3 emissions. Scope 1 and 2 are basically the use phase. So it's the energy efficiency during the use phase. Scope 3, the embodied, so during manufacture, etc. We don't have a good handle on. We're only just starting to get to that point where we're beginning to understand what's actually involved in that area. Data centers sustainability. So I've talked about carbon neutrality and net zero in general terms, with a slight reference to our sector. But really what I want to do now is go into a bit more detail around the specific applications to data centers. The first thing I'd like you to think about is some of the statements that are currently being made by companies. We hear a lot about net zero from some of the larger companies in our sector. some of the larger multinational organizations. Are those announcements that are being made really commitments towards net zero? Firstly, are they merely talking about carbon neutral? Are they talking about genuine net zero? Are they merely marketing responses to, what is ultimately a groundswell of opinion that feels we should be doing more in this area? Is it merely a response to the threat of regulation or legislation? Or are they actually making genuine strides to move in the right direction? And I think the jury's slightly out as to which one that is. I mean, there is absolutely 100% a greater potential for legislation and regulation. A number of governments around the world are saying, we are considering legislation for many sectors, but particularly the data center sector. We've got a pretty large target painted on our backs right now. We use an awful lot of energy. There's a lot in the media about the amount of energy that we consume. And it's very, very difficult for us to defend the use of that energy. I always say if we're talking about steel manufacture and manufacturing a ton of steel, we can demonstrate that we're improving our energy efficiency by using less energy to manufacture that ton of steel. Very, very difficult for us in the data center sector to do that. What is the ultimate product that we produce? Well, it's probably a service. And how do we measure the value or the energy intensity or the energy efficiency of that service? Really very difficult. Again, as I've already said, do these statements really mean carbon neutral rather than net zero? And I think you'll find they in many cases do. And I think it's worth, if you're hearing these statements or seeing these statements, then having a look at what's actually behind the statements to understand really what's going on. As I said in the previous slides, many of the elements that are required for genuine net zero go beyond just the control that's available to data center operators. Reusing waste heat or the performance of the IT load. Yeah, all of those sorts of things are certainly things that can be applied, elements that can be applied. But actually, it requires to be far more joined up. All of us within our sector to be far more joined up. This isn't just about the building. This isn't just about the IT. This isn't just about the intervening network. This is also about the manufacturing processes. This is also about the way those systems are set up to work. Are they actually going to quiesce properly or just run flat chat without any load on? There's a lot of stuff that we can do in there to be far more joined up that we really haven't started to get involved in too much detail yet. What about the cloud? You'll hear a lot from cloud providers saying that they're basically reducing their or looking to reduce their carbon output, to reduce their emissions, and some have set 2030 targets. You know who they are. You've seen the statements. I think it's a bit of a challenge on the basis that certainly within the media, the uninformed media, admittedly, but within the media, often the large cloud providers, the hyperscalers, are seen to be exemplars of our business, of our sector, and that's not strictly true. They operate a very, very specific business model. They're effectively operating very large enterprise sites, so it's very difficult to compare those enterprise sites that they operate with the, dare I say, the more generic co-location sector. And they also have very, very focused, targeted equipment within those large enterprise sites. The hyperscalers define what is going to go in there. They have the luxury of being able to do that because they are effectively operating as an enterprise in that context. They define their own stack. They can run that stack very lean. They can do all sorts of things that, frankly, the rest of the sector may not be able to do. So I think the idea that they represent the sector as a whole is I think a little bit of a distraction, to be honest. And I think increasingly beyond that, the use of cloud really obscures a lot of the issues that we have in our industry in terms of trying to solve net zero issues and meet some of the net zero requirements. A lot of the time, we simply consider the data center to be a building, unfortunately, and that makes it very simple in a way, and it gives us some targets that we can aim for, but actually it's not the real problem, and I'm going to go into that in a bit more detail in subsequent slides. But cloud, I think, really does obscure the use of energy in our sector, and I think it's increasingly obscuring it, and I think that we don't really have a lot of data on the true energy usage within cloud. So again, and I'm going to talk about that a little bit more in subsequent slides. Finally, as I mentioned earlier, we're a long way from getting a grasp on scope 3. You know, the embodied energy, the amount of energy that, the embodied carbon, the amount of carbon that we're actually using or outputting during the manufacturing process, during the refining process, and during the disposal process of equipment generally. Not just the building, again, not just the construction materials, but the IT materials, et cetera, et cetera. So what about energy efficiency? Let's go into that in a bit more detail. And it's worth noting that energy efficiency and sustainability are not necessarily the same thing. So again, if we go back to scope 3, scope 3 is very much a sustainability issue. You know, how much embodied carbon are we creating? How do we measure it? And that's difficult right now. The use phase energy efficiency is a different thing entirely. So what is data center energy efficiency? Well, it's actually very, very elusive. You'll hear lots of people talking about energy efficiency in data centers, but very few of them, I think, are really hitting the nail on the head. Some people are actually, frankly, completely wrong. We tend to focus on PUE as a proxy, and obviously I can't possibly do a data center presentation without talking about PUE, much as I hate having to do so, but we have to put it out there. We do use PUE as a proxy in this, but as I repeatedly say, PUE is not, and never has been, and never will be, a measure of data center energy efficiency. Okay, so that said, and I'm sure someone somewhere is going to argue with me on that, but I know I'm right. I'm going to be very pedantic about it. What should we be looking at? Where is the focus? What is energy efficiency in a data center? Okay, well, let's just think about it. Is data center energy efficiency all about the building? Is the data center the building, or is it more than that? Surely data centers are about the service that's being hosted within the building. It's not about the building alone. You know, if you've got no IT load in the building doesn't consume any energy. The building merely puts a slight overhead, or it should be a slight overhead, on the energy consumed by the IT load. And that is effectively PUE. So difficult challenge. How do we actually achieve genuine data center efficiency? Well, if what we're saying is true, if the data center is a service and the important focus is the IT load, and the building is merely putting something of an overhead on the delivery of that IT load, then surely we should be focusing on the IT side of things, the services, the compute, the storage, the network, and very importantly, the software that runs in our data centers. And I think there's a really important thing here, that we are going to be scrutinized by regulators. We are going to be potentially legislated against. So how do we actually demonstrate to potential regulators and legislators that we're actually doing the right thing and following appropriate guidelines, etc.? You know, because we are under the microscope. Don't misunderstand the media attention to what we are doing in data centers. You know, whether we're consuming too much energy, or the wrong kind of energy, or the wrong energy in the wrong places. You know, we are under the spotlight. Make no mistake about it. So we are. Again, as I said earlier, we do have a pretty large target painted on our backs. And so, you know, we are going to be forced to respond to this one way or the other. Oops, one too far. So again, as I've already suggested, PUE is absolutely not the solution for data centers. It's not the way that data centers can reach net zero. It's not even the way data centers can achieve carbon neutrality. PUE won't actually help us. So we need, as a sector, to stop focusing on PUE. We need to get governments to stop focusing on PUE. You know, what they've done in Amsterdam in terms of putting a moratorium on buildings that are operating at, I think it's, more than 1.3 PUE or something like that. Can't remember the exact details, but putting a moratorium on that is not helping anybody. It's not achieving anything useful whatsoever. So we need to educate our sector, we need to educate governments, we need to educate the public, and we need to educate the media as to what actually is important. You know, an energy efficient building with a low PUE is not necessarily an efficient data center at all. You know, if you've got a data center with a very low PUE, but the IT load is just spinning, doing nothing, that's hugely inefficient. It's serving no useful purpose. And putting a data center underwater is a marketing gimmick. It's not helping anybody. It's just a distraction. It doesn't really make any useful sense. Yes, you're achieving a pretty good level of cooling. Again, you're just moving it somewhere else, so that's not maybe particularly helpful. But at the end of the day, you're still consuming power on the IT side. What's been done to reduce the energy consumption of the IT? As far as I know, nothing. It's exactly the same as it would be if it were in a building. So again, it's not energy efficient. It's doing exactly the same thing in a different way. So I would suggest that the IT load and the equipment itself, the IT equipment, and that it does include obviously intervening network as well. It remains not just an elephant in the data center, it's an absolute herd of elephants rampaging through the data center, causing chaos. The more we focus on PUE, the less we are potentially able to get a handle on the IT element and potentially even do something about it. So I'll give you an analogy. I talk about the house, your house. Your house may be immensely thermally efficient. You may have triple glazing. You may have walls that are 2 feet thick full of foam. You may have loft insulation 3 feet thick. Fantastic. You have got the most efficient house on the planet. You might even describe it as energy efficient, depending on what you've actually put inside it. But if you've got a hot shower running all day in your house, and nobody's using that hot shower, it's running for no useful purpose whatsoever, but it is absolutely consuming energy. It's also consuming water, by the way, which is another potentially precious resource, depending on which part of the world you're in. But if you've got this thing running all day, doing absolutely nothing useful, you cannot blame the house for being inefficient. You cannot blame the house for a lack of energy efficiency. And what we're doing at data centers at the moment is we're blaming the building for being inefficient, when effectively all we've got going on in the data center at the moment is the hot shower running all day without necessarily being used by anybody. We've got IT kit, which is spinning, doing nothing potentially, or is very lowly utilized, average utilization rates being what, 15, 20% possibly. Zombie servers aren't connected to, even connected to network. We've got all those sorts of things going on, and yet we're, navally gazing, focused on the building with PUE. Absolutely the wrong focus. So when it comes down to energy efficiency, think about the house, think about the shower. I suggest the most useful thing you can do is actually turn the shower off and only have it working when you need it. It sounds a little bit simplistic possibly, but I think it's probably the right way to go. Really think about how your energy is actually being used, not just some proxy metric that is actually not really representative of what we're trying to achieve as a sector or as an industry, and certainly as a society moving towards net zero and net zero commitments. So defining data center energy efficiency, the challenge. As I suggested earlier, is the data center a building or a service? I would strongly argue that it's ultimately a service. It's a service providing, and I know it's a word that was probably last used 20 years ago, but we're hosting IT equipment, we're hosting IT services. PUE presumes that it's the building, but it's wrong. It has to be wrong. It is not a building. A building, again, merely provides an overhead. If you take all the IT load out of the building doesn't consume any energy. Fairly simple and straightforward. True energy efficiency, from a purely physics perspective, must be based on useful work done. So, what is the useful work that's being done? And I go back to the analogy of the ton of steel. If we actually know to a very sort of fraction of a cent, fraction of a pence cost of what it actually costs us to produce that ton of steel, we can reduce that cost and we can reduce the energy associated, which of course, again, reduces cost. We don't have that luxury in our industry. So we have to think of some way of producing a metric, or probably more likely a series of metrics, that allows us to actually accurately measure and report energy efficiency. As I said earlier, we've just been navel gazing so far at the building. We've got to move beyond it. And remember the analogy of the house and the shower. I think also there's, again, as I suggested earlier, something of a smokescreen with relation to cloud. We do consistently fail to measure the energy costs of IT services. Very, very difficult to do. For instance, is it more energy efficient to look at a video clip on your phone or on your large TV, you know, your large sort of, let's say 55-inch or whatever screen at home. Well, actually, when you think about it, it's actually far more energy efficient to look at the, you know, the cat video or whatever you're interested in on your phone rather than the large screen back at your house. May sound a little bit counterintuitive, but actually those sorts of things are important. And when we come to looking at energy efficiency in the IT sector, there are lots of sort of conundrums out there and things that are not immediately obvious or even counterintuitive. So again, let's move away from the soft target, the building, and think about what's really consuming the energy efficiency. And cloud really actually makes this more difficult and possibly worse to pin down. And it certainly obscures the true energy cost. The suggestion that cloud's actually more energy efficient is probably not correct. I mean, you'll hear that all over the place. You know, the cloud is reportedly more energy efficient. Well, I don't really think it necessarily is, and I certainly haven't seen any data that backs up the statement that it is. If you think about the fact that cloud relies on essentially geo redundancy or application level redundancy, that requires therefore that you have to have sites and equipment sitting out there that are probably very lowly utilized, very low utilization rates, which suggests that they're obviously ready and waiting and consuming energy. I don't think there's anybody out there that's switching on a data center in order to replace one that's just gone dark. It clearly doesn't work that way. So it's sitting there ready and waiting. And you'll hear about some large hyperscalers, cloud providers talking about their ability to do away with generators. Well, yeah, absolutely. Relatively easy to do that if you don't mind a data center going away. If you don't mind that data center going dark, you no longer need the generators. And certainly the hyperscalers, if you talk to many of them, are building tier 1 type data centers. They're not building your traditional tier 3 co-location type sites. They're building something very different because they can afford to lose sites potentially. And for that reason, yeah, do away with UPS and generators as well. However, it's not quite as simple as that. You're not merely eliminating that greenhouse gas emissions. You're just moving it somewhere else. You're moving it to another site, which is sitting there ready and waiting and still consuming resources, possibly consuming more resources than a generator would if it was switched on and you only had a single site. So again, the idea that cloud is better, more energy efficient, and better from a carbon neutral or net zero perspective is not necessarily true. And I don't think an awful lot of work has been done on that to prove the case either way. One question I would ask is, are you given relevant energy usage stats and efficiency calculations by your cloud provider? I don't know of any. Maybe I'm wrong. Maybe you guys out there are seeing something different and you've got a lot of detailed information about how your cloud provider consumes its energy and reports it back to you. But certainly as far as I've seen, there's not a lot of information out there that allows you to make informed decisions about how your cloud provider is using energy and which cloud provider you maybe should be using to improve your own energy consumption levels and therefore carbon emissions. I think this situation is something that actually does need to be improved quite dramatically. Claims of improved energy efficiency, I think, do need to be substantiated. Information needs to be more available if we're going to actually be allowed or able to make informed choices about energy consumption, energy efficiency, energy cost, energy overhead in terms of using the cloud. At the moment, it's pretty obscure, to be honest, which is why I call it something of a smokescreen. So how are we doing so far? There's some areas we're doing pretty well in, actually. Certainly the use of renewable energy has become something of a major site selection criteria, and even what I would call a sector differentiator. Customers of data center operators and cloud operators are certainly very interested when they're making their choices about what sort of energy they're consuming and how they're consuming it. So yeah, renewable energy is an absolute driver, which is a good thing ultimately. However, one thing I would caution against is, yes, use renewable energy, of course, and yes, highlight the fact that you're using renewable energy, and again, yes, that's a very good thing. But it doesn't mean we should simply be profligate in our use of renewable energy. Just because we've got renewable energy doesn't mean that we should just basically say, right, that's great, we can use as much as we want, and we can continue to consume with abandon without necessarily considering the implications. Because of course, there's something of an irony at the moment that sustainable energy is not particularly sustainable, in the sense that we don't have very much of it. There's not enough to go around. So we do need to continue to be somewhat careful even about renewable energy sources, until we have a 100% renewable energy infrastructure, which we are obviously a long way away from. We need to be overly cautious, and again, to continue to focus on energy efficiency in terms of actually looking at sustainability about overall energy emission, energy usage and greenhouse gas emission. So again, just because it's renewable doesn't mean it's necessarily a good thing in the way that it's being used. Carbon neutrality, as I said earlier, is simply moving the problem elsewhere potentially. Don't confuse carbon neutral statements with net zero. And again, I think they are used interchangeably without much thought. It's worth asking the question, if people are claiming net zero in particular, how are they achieving carbon neutral? Is it merely offsets? Are they buying it from somewhere else? Which again is just moving the problem elsewhere. So, people are talking about it, which is great. People are putting out marketing messages about it, which is great. That might be a response to threats of legislation, but ultimately it's good that people are aware of it. I think it just needs a little bit of push in the right direction to make sure they're not just aware of it and making statements about it, but actually doing something useful. We do have a long way to go when it comes to embodied carbon, the scope 3. There's a long way to go on that. We don't really know, particularly if you look at the IT equipment again, how much embodied carbon is there in a particular manufacturer's servers, and it's very difficult. It's difficult for the manufacturers. They're not necessarily avoiding the issues. Very difficult to pin down what goes into the components, and of course, servers have different configurations. The equipment we use has different configurations, so you've potentially got an infinite list of different types of equipment and model numbers and configurations, all of which will have obviously different values, and we're only just at the beginning of this. We've got a long way to go. Doesn't mean we should stop, because it is important, but equally we do have some considerable way to go. Don't merely follow the hyperscale operators as exemplars. They're different. They have a unique use case. They have a different business model. They're not exemplars of our industry. And I think at every opportunity, we'd stop referring to them as being the direction to go in, or even a possibility of the direction of travel, and make it very clear to people in the media that use them as exemplars that it's not necessarily the case. The elimination of diesel generators, and could we be using fuel cells or hydrogen or large battery arrays? Yeah, all of the above are possible, but I think it really is predicated by the business model and what's going on. And again, if we are going to be doing things of that nature, taking out those protection mechanisms, which is what they are. They are standby protection mechanisms for utility power loss. If we're going to be taking that protection away, then we've got to make sure that we're not really moving the problem elsewhere just by essentially having a backup site running continuously, consuming as much energy again potentially as the site we're trying to protect. That's not really helping. It's actually consuming more energy ultimately than would be or more greenhouse gas generally than would be consumed potentially by the generators. And the same is true of refrigeration gases. We're obviously increasingly around the world moving towards less damaging refrigeration gases. That is happening, but of course, we're still using a lot of harmful refrigeration gases, even though the worst have been largely removed from service now, and we've got a long way to go. So think about mechanical refrigeration. Is it necessary? Should we be moving away from it, even as a backup? And should we be thinking about how we're constrained by the likes of ASHRAE, etc., to certain environmental envelopes? Are they still appropriate? Are they relevant? And should we be looking beyond that? Possibly. The future. What does the future hold? Well, beyond where we are now, which I've really just covered, I think there's a couple of areas we can potentially look at for the future. Because I'm involved in standards and metrics, I'm inevitably bound to say that we need standards, metrics, KPIs to be able to do any of this. We need to be able to measure energy efficiency. We can't do it at the moment. We cannot in any useful way measure energy efficiency in data centers. We can't even properly define what a data center is. Is it a building? Is it a service? Is it the IT? Is it the intervening network? Well, it's actually all the above, everything. So, and we've got one area that we do define, and again, referencing PUE, we've got, a measure of the energy overhead that the building puts on top of the IT load delivery. Great. That's one area. It's not the whole thing, as I said earlier. Just creating one metric to rule them all, kind of using my Lord of the Rings analogy, it's not really particularly helpful. It's not going to work. People have been looking for that one metric for at least 10 years, and they've used multiple types of different proxies to try and get there. They're either all far too complicated, far too inaccurate, they just don't work. So I think ultimately we'll end up with a suite of metrics, KPIs, that will help us to report on different aspects of energy usage, and not just energy usage, other sorts of resources. So, things like water usage, carbon usage, various factors that will come in. One metric that will do the whole thing, I think it's highly unlikely, if not impossible. So I think we should be thinking in those areas, what sorts of things should we be usefully measuring? Well, applications, software, hugely important. The efficiency with which software is running on the IT hardware that sits in our data centers, actually, I think is something that we should be concerned about. Electricity is not free. I think if you were to have a conversation with many software developers and ask them how much the electricity costs, they'd give you an answer that suggested a very, very low value. And, some might even think, well, from a processing perspective, it's free. I don't pay the energy bill. Why should I care? I'll just develop my lovely and efficient code. It'll do some very lovely things and be very clever, but it's not going to be very useful when it comes to reducing energy consumption, I'm afraid. So, I think that hurdle has to be overcome. So looking at the way that software works, its effectiveness, I think is actually a very important element, and one it is becoming increasingly recognized. I've thrown a few metrics out there. So these are absolute crystal ball, pie in the sky, put out there without any real consideration or thought as to what might be practical or even potentially useful. But, cloud delivery effectiveness, we have water usage effectiveness, carbon usage effectiveness, power usage effectiveness. How about cloud delivery effectiveness or something of that nature? Going back to how obscure it is to get, effectiveness metrics or even efficiency metrics from cloud providers. That might be an interesting one. Don't know how it's going to work. Don't know how it will be put together, but I think it'd be a useful thing to have. Application delivery, network delivery, converting electrons to photons and back again and then firing down a piece of glass is actually a pretty energy intensive business. So let's not forget the intervening network. And of course, if we are looking at geo redundancy or application redundancy, then that becomes even more of an issue. Moving bits around the world is actually quite expensive in terms of energy. So, something in there might also be useful. And I think we've also got to consider, and this is why I think standards and metrics are so important. We've also got to consider very much how we respond to the threat or likelihood even of regulation. How are we going to tell regulators that we're doing a good job? How are we going to tell regulators that the legislation they're proposing is actually inappropriate? And a lot of it will be, you can guarantee it. How do we show that we're following appropriate guidelines or best practices? Well, actually, the only way we're going to be able to do this is by using some sort of standardized benchmarks, be they KPIs, metrics, whatever. And ideally, they'll be international. Ideally, they will be, not just specific to individual nations. They will be something that we can actually talk of internationally across our entire sector rather than just in one location. But we've got an awful long way to go on that yet. To be useful and for both our sector and ultimately for legislators and governments to pick it up, we've got a long way to go. We're not even actually using the ones that we've currently got properly. So again, we've got a huge way to go on that. So a few key takeaways, a few areas just to sort of to start to wrap things up. Sustainability is not just about green energy. It does have a huge part to play. So just because you've got renewable energy, just because you're using hydro or wind or whatever it is, doesn't mean you're necessarily being sustainable. There's an awful lot more you've got to consider. You've got to consider your scope 3, your embodied carbon. You've got to, you do, even if you're using renewable sources, you've got to consider your energy efficiency across the board, because renewable energy currently is a somewhat limited resource. We're not 100% renewable. None of us are. It's about choices made. It's about disposal. It's about choices made in the kind of equipment that you're buying. It's about how that equipment's operated. It's about the applications of software that are running on that equipment. All of those play into sustainability. It's not just about energy efficiency. It's not that simple, I'm afraid. It's really, as I said in the second bullet, it's really about the more effective and efficient use of the limited resources we have available, and that's across the board. And we ultimately need to get more benefit for the electrons that we consume. We're pumping energy in, we're throwing heat out. How can we actually improve that? How can we either throw less heat out, do something with it? And heat reuse is a big topic right now. We talk about it on a routine basis. The problem with heat reuse is you've got to have a customer for it. It's all very well, we've got the technology that can reuse heat. Fantastic, great, but who's going to take it? We can't move it very far, so it's got to be used close to the point of origin. So who's going to take it? There are a few interesting ideas. My personal favorite is build a brewery next door to your data center. Use the waste heat to dry your malt and warm your water, and hey, fantastic product at the end of it. That's my personal favorite. Probably not very sustainable in terms of the number of breweries we need and the number of data centers that we have, but nevertheless my favorite. And I'm available to anybody to do research in that area if needed. Mainly tasting the beer, I suspect. Genuine net zero does require a reduction in greenhouse gas emissions. We can't just move it elsewhere. We can't just go down the carbon neutral route. So I think we should all be aspiring to true net zero, but also we should be understanding what it means. And for those claiming net zero or net zero targets, we should probably hold their feet to the fire a little and make sure they are genuinely going in that direction. We talked about embodied carbon beyond the use phase, scope 3, etc. It's hugely important. We need to be thinking about it, but we've a long way to go on that area. We're only just beginning to get even sort of start to get a handle on it. There's some way to go. I firmly believe we should be focusing on the services hosted within the data center, not just the building. The more we focus on the building, the more we allow the media to focus on the building, the more we focus on the building as a sector. Firstly, we're I think in well-run sites now, we're at a point of diminishing returns. Once you get down to about sort of 1.1 or even 1.2 PUE, etc. There's not a lot more you can do in the building. Yes, I know there's going to be all sorts of people that challenge me on that, but realistically, apart from some of the outliers out there, if you're at 1.1, sort of somewhere between 1.1 and 1.2, you're doing a pretty good job. And where do we go from there? So if we continue to to focus on the building, and we're just going to be hiding the real issues, it's not really helping. The final bullet, though, I'd like you to take away with, and if you're ever having a conversation with government or media or anybody else who's likely to have a bigger influence than certainly I would, then I think it's worth pointing out that digital infrastructure, which obviously includes data centers, is ultimately going to be the enabler. We probably can't achieve net zero or even carbon neutrality without the use of digital infrastructure, without the use of the data centers that host that digital infrastructure and connect that digital infrastructure together. Without the ability, the processing power, the data storage, the analytics that's provided by our digital infrastructure, we are probably not going to be able to achieve net zero, not true net zero. How on earth do we measure it? How do we control it? It's bigger than a human problem. It's got to be an IT solution. So while we are absolutely, as a sector, consumers of energy, are we part of the problem? Of course we are. And do we need to do better? Of course we do. But without the services that we provide and the infrastructure that we maintain and the people who run our data centers and our digital infrastructure, then we probably, as a species, will not achieve net zero. So yes, we need to be aware of what we're doing and do better, but actually, we are very much part of the solution, not just part of the problem. And that is it from me. Any questions?
All right, great job, Mark. Really useful information in here. We do have some questions rolling in, so I'm gonna go ahead and get started with asking those. And for those of you who have not asked any, please feel free to ask as many questions as you would like, and we will try to get through them. We have almost about 10 minutes left to answer your questions. So the first one for you, Mark, what are some strategies that facilities can take to reduce embodied carbon? What should we be looking at?
Yeah, I think embodied carbon is our biggest challenge. It's really it's about. I think there's two areas. You know, if we think about the building and then the IT side of things, certainly from the building perspective, you know, if you've already got a building and it's built, then it is what it is. You know, and the thing to do in that sense with an existing building is basically not knock it down and you know, build another, or you know, once it's built, it's there. Let's not worry about it too much. But I think when we're going forward with new buildings, then think about the construction materials that are used, and think about the air miles that the materials actually have to travel when they get to the site. So it's very much about working very closely with, you know, your general contractors and your designers, your site designers, to make sure they're using the appropriate materials and that they are reducing the embodied carbon. You know, there are low carbon cements and concretes available, for instance. And then on the other side, on the IT side, then yeah, absolutely, conversations with the IT OEMs and understand what they're doing from an embodied carbon perspective. You know, to what degree they understand the embodied carbon of their equipment, to what degree they can report and tell you, you know, what the overhead is for the equipment that they're, you know, proposing selling to you. So I think there's a conversation there, and I think the more that we're asking, be it the IT OEMs or the data center designers, you know, the MEP consultants, or the general contractors on the construction side, the more we're asking those questions and forcing them to maybe think of good answers, the better we're going to be. And then also at the back end of it is equipment disposal. You know, when you are disposing of it, think about how it can be most effectively disposed without increasing the you know, the burden on the environment. And in fact, in some cases, you know, is it recycling? Is it reuse rather than disposal? You know, that's the circular economy is actually something that's emerging massively, and I think is something that we should all consider.
Excellent, thanks, Mark. We got another one here. Are most companies just buying green power? Do you ever see data centers with solar or wind on premise?
You do, but the problem with solar and wind is energy density. So if you think about it, and I may get this wrong, so I'm prepared to be challenged on this, but if you think about the energy density of PV, so solar, you know, what are you going to get? Probably 100 watts a square meter, something like that. I don't know. And again, I'm quite happy to be corrected. But if you think about it, you know, we're currently building data centers at 2 kilowatts or even, you know, often 3 kilowatts a square meter. So there's an absolute energy density mismatch when it comes to PV. You know, can it be done? Yep, but you need a huge acreage to achieve anything useful from a PV perspective. And then, of course, with PV, you know, we have this thing called the night, when we're not actually generating any electricity. So we've got to have quite a lot of energy storage, and that's probably going to take the form of a battery, which has its own environmental impact when you're, you know, manufacturing it and using it. And so, you know, PV and wind, it's about energy density. It's about stability. Are people using it to augment their position or make their position better in terms of putting less burden on, be it the grid or other renewable forms of energy? Is it happening? Yes, but it's pretty limited. It's all about energy density and stability. So in that sense, it's not probably mainstream.
Excellent, thank you, Mark.
Very good. You can put a few PV cells on the roof to trickle charge the batteries if you want, and a lot of people do that and claim that they're using solar. Slight smoke and mirrors, though, in that case.
Yeah.
Thank you, Mark. We've got quite a few coming in asking about if this slide deck will be shared, and yes, it will be. We'll share both the recording and the slide deck shortly after the presentation. All right, moving on. We got another one here. Granted that PUE is inherently flawed, what are the best contenders to represent the power effectiveness of the facility, including both the IT and the underlying M&E infrastructure?
Well, there isn't one, and that's the problem. We don't have a useful metric, and I think the likelihood of us having a single useful metric are pretty much zero. And this is the challenge, so think about the different types of data center that we have. If you're streaming videos, for instance, you're going to have a pretty storage intensive data center, and it's going to have a huge network component. Your biggest overhead is likely to be your network traffic. If you've got an HPC data center, very little network traffic, probably huge amount of processing going on, literally running, you hear stories of 50, 60 kilowatts a rack on HPC sites doing absolute number crunching. They're effectively batch processing, right? And the output, if you're doing, let's say, a weather map, huge amounts of processing, the output is probably a few gig of maps. It's not particularly big. So, we have all sorts of extremes in terms of what data centers do, how they perform. The idea of having one metric that covers all those, I think, is fanciful. I think what we're more likely to do is have a series of metrics, almost a kind of a matrix type system, which we use to report different aspects. And we have PUE, and we all know it's flawed. But actually, as an operational metric, in terms of understanding the building overhead that's being put on top of the IT load, it's a useful metric. So I will never say PUE is not useful. I just think it's used in frequently the wrong way. So we have that. We are currently ISO are putting out renewable energy metrics. So you've got the REF, renewable energy factor, coming out. You've got ERE, which is energy reuse effectiveness, ERF, energy reuse factor. So how much energy you're actually reusing. Waste heat, as we've discussed earlier. You've got water usage effectiveness. You've got carbon usage effectiveness. You can't put all those metrics together and create one overall metric. It just doesn't work that way, because you just come up with some nonsensical figure that doesn't really mean anything and has no real value. So I think what we'll have over time is an increasingly sort of as a matrix of KPIs, which we'll all use to report and say, these are the things that we're covering, and this is how we're doing in this particular focused area. And one area that we don't have yet is obviously metrics on the IT side and the software and application side. So I think it's more of a matrix rather than one metric. And do we have anything that can replace PUE right now? No, simply put.
All right, thank you. Moving on to the next one, and this might be our last one. We might squeeze in another one, though. Let's see. So as for the software application efficiency, most of the IT hosted or on the cloud is owed by end customers. How do we evaluate that, and how the KPIs should be set?
Well, I think the onus is on people to realize that energy is not free, and I get the point, and that probably comes from someone who's with a co-location operator, and yeah, it's a challenge. But I think what we need to do is move away from the media and government and probably even ourselves from blaming the building, blaming the colo operator or the building owner or whoever for being inefficient. We to that point, we can manage what we can manage, and we can't even necessarily manage PUE, right? Because if the IT guys who own the equipment don't deploy the equipment correctly, and they don't manage their airflow, and they don't put their containment in, and they put everything the wrong way around and don't measure in the right places, and they're going to destroy the PUE anyway. So another reason for moving away from it, we need to be as efficient as possible in what we can control, but we need to make absolutely sure that there's a realization that there's an awful lot that we can't control, and that those people who are responsible for controlling it, who are responsible for buying IT equipment and requesting code to be developed and buying software, the purchasing criteria and the development criteria and the deployment criteria need to have more energy efficiency based in there. That's the only way we can do it. So, which is why I say we should move away from beating ourselves up from a building perspective and PUE, and actually move the problem, not move the problem elsewhere, but focus on the fact that the real reason for the problem and the thing that should be measured is actually elsewhere. and make the people who are responsible for those elements, who are not, specifically co-location operators, make the people who are responsible for those elements aware that they're responsible, and encourage them strongly to do something about it. Which is why I think legislation that's based on the building is going to be so harmful, because it won't actually achieve anything. It'll just irritate an awful lot of people, make things very, very difficult for an industry that's actually doing a pretty good job of managing itself, and again, actually achieve nothing particularly useful.
Excellent. Thank you, Mark. And I think we're going to wrap up here. We're a couple minutes over, so we appreciate all of you staying on for these questions. If we didn't get to your question, we will follow up with you directly after the webinar. But thank you all so much for joining us. Mark, thank you so much for joining us and presenting this very important topic. We really appreciate having you here today.
Thank you, Isaac. Thank you, Uptime, and thank you everybody out there for listening. Thank you.